Okay, here's an intro to experiment 5, empirical formulas. In this lab, we are coming up with the empirical formula that would form between magnesium and oxygen. So what we would be doing is taking solid magnesium, placing it into this crucible, and burning it with oxygen from the air. And we're making a compound, Mg, little x, O little y. So the point of finding an empirical formula is to determine the values of these x's and y's here, the mole-to-mole ratio. Now from our periodic table, we know that magnesium has a charge of +2 and oxygen -2. So this one we can actually predict that the empirical formula should be a 1-to-1 mole ratio. Of course, lab doesn't always turn out that way. So we'll be using the measurements given and provided in the data to then calculate and see the empirical formula that we come up with. You'll be doing all the pre-lab questions. And then here you'll be provided the data for both trials. But what I'm going to do is actually run through just a sample calculation here. So what I'm writing does not need to go into your lab manual. I'm just going to run through a practice to show you the calculations. So here, I'm going to ignore the mass of the lid for the moment. Let's say the empty crucible and lid had a mass of 35.9242, and then we put some magnesium in there, and we got a mass of 36.1142. Then we could subtract these two values right here to figure out how much magnesium we started with. So we would take 3 minus 2 and find that we started with 0.19 grams of magnesium. But careful with the sig figs again, because if we're subtracting, we've got 4 sig figs, 4 sig figs, so we're going to, 4 decimal places. Not 4 sig figs, 4 decimal places, 4 decimal places. That means we need to keep 4 decimal places. So we've got to make sure we keep those zeros. Okay, what we would then do is burn this crucible in magnesium, and the mass would begin to increase because oxygen is coming into the crucible and forming a compound with magnesium. So the mass rises. So after our first heating, let's say our new mass was 36.2342. We see that it did go up. We would then heat it again to see if the mass continued to go up. So here in this example, I'm going to say the mass stayed the same. That tells us that the reaction is complete. All the magnesium has been used up, and there's no more compound that's forming. So if we come down here, to get to moles of magnesium, we're going to take our grams of magnesium that we just found and go grams to moles. So we would take 0.1900 grams. And that would give us our moles of magnesium. We started with 4 sig figs here, so now that we're dividing and multiplying, we want to keep with our sig figs. So here I'm getting 0.007816. I kept all 4 significant figures to get the moles of magnesium. For the mass of the compound, we come up here and we see that what this 36 value down here is the crucible, the lid, and the compound. So what I really need to do is get rid of the crucible and lid so that I know the mass of just the compound. So I'll take this 36.2342 and I'll subtract just the crucible and lid. So for this one, we're actually taking number 4 and subtracting 2. And when we do that, we need to look at number of decimal places since it's subtraction. So 4 decimal places will be kept. So this comes out to be 0.3100. That's the mass of the compound. So then if you think about this, here we're looking for the mass of oxygen in compound. So this compound right here has magnesium and oxygen in it. So what we need to do is take the compound's mass, which we have, and subtract out the magnesium's mass so that we are left with just the oxygen. So in this case, the oxygen in the compound was 0.1200. And then to go mass to moles of oxygen, we're going to use our molar mass again. So for oxygen, it's 16. So 0.12 divided by 16. And since we're multiplying and dividing, we started with 4 significant figures. We're going to keep 4. So I get 0.007500. And that is my moles of oxygen. Now, whenever we're looking for an empirical formula, it's moles that we really care about. So the 2 important values here are the 2 moles. We've got moles of magnesium and we have moles of oxygen. So what you always want to do is take those 2 and divide them by the smallest one. So I would take the smaller one is 0.00755. So I would do 0.007816 divided by the 7.5 and the 0.0075 divided by itself. So we'll see that it comes out to be a 1-to-1 mole ratio, indicating our compound has subscripts of 1, and that's our empirical formula. And then for percent by mass, if we focus on magnesium first, we're going to go see what the mass of magnesium is, which in this compound it was 0.1900 over the full compound, which was 0.3100, and then multiply by 100. So the 0.19 divided by 0.31, and here we get 61.29%. And then percent oxygen, we're going to do the same. The 2 percentages should always add up to 100, but percent oxygen would be our 0.12 over our compound mass. And so we would get there 38.71%. So that's how you'll complete the calculations. You'll have 2 trials of different data to run through, but that gives you an example of the calculations. And then you'll complete the post lab.